This term, and it's a packed house. How are we gonna, yeah. So today and on the poll, you all said you wanted to go through exam style questions, so that's kind of what we're going to do. We're going to talk about the exam today. Then we're going to do questions that are similar to the exam, so you can kind of see what it looks like. And then we're going to take it from there. I'm just going to preface as well to say about a third of the students have started assignment 2, and I would really urge the other 2/3 to start the assignment 2 as well, because you don't want to be pressured right towards the end, kind of struggling to, you know, to get through it. All right, let's get this party started. Oh yes, okay, so at UNSW we have this thing called My Experience Surveys, and they are this thing that you guys fill out and it comes to us and it lets us improve the course because it tells us how you found the course. Yes, it will not affect you because you'll be gone from the course, but the changes will affect the people that come after you. And in 1511 we do take the feedback very seriously, and we do act on a lot of the feedback that we receive. But again, keep your feedback constructive. So, you know, keep it nice and constructive. There's a lot of people working hard to make this a nice course, and we want to continue making it a nice course and a nice introduction to students for their first programming. All right, the exam. Who's feeling good about the exam? Who can't wait? Yeah! Bree, you're excited? That's nice. You've done this exam a while ago. Okay, the exam is going to be on the 9th of May, and it's going to have on it, in a surprising development, everything that we have learned so far. So lots of focus, if statements, while loops, obviously you'll need a lot of them for arrays and for linked lists, so that kind of goes without saying. Shh. I know the exam is super exciting, I feel that. Thank you. Okay, lots of variables, lots of strings, arrays, pointers, linked lists. It's going to have a little bit of everything that we have learnt so far. And hopefully you will do great. Okay, some of the admin details. The exam is on the 9th of May. There is going to be 2 sessions on that 9th of May. It's going to be a morning session and an afternoon session. And for those of you in the afternoon session, you're also going to be locked in a room for 30 minutes. Woo! And it's called correlate. Yes, it's not really a fun locked in a room. There's no like escaping that room, so you just have to sit there. So you will be, you'll get an email in the next week or 2 that will let you kind of choose which session you prefer to be in, and we will try to put you into the session that you want to be in. However, if you have an exam clash, you will be automatically allocated to a session that doesn't cause that clash to happen. And if you don't reply to the email, you will also be automatically allocated to a session that has time. So reply, don't reply, you're still doing it on the same day. You might just be, if you're not a morning person, if you have a long way to travel, you might want to be in the afternoon, or if you just want to not have it in the morning first thing or want to do it first thing. So the morning session is 9:45 till 1 o'clock. Then those who are doing the afternoon session have to arrive by 12:50, and the corralling doors close at 1 o'clock. That means you will miss out on the exam if you come past 1 o'clock. Do not be late to your exam. So, and then you're let out at 1:20 when you will go to your allocated exam room. So after you choose your preferred session, a little bit closer to the exam, you will also receive an email that will tell you where it is that you are sitting in the exam. It will have the room and the seat number. For those of you that are being corralled, you will find out more in there as well. It will just tell you that you're being corralled, okay? And you will have to go to that assigned seat. Okay, the lab next week is a sweet, sweet lab that is a prac exam, okay? And that prac exam will have questions that are similar to the exam questions in the style, the difficulty, the way the questions are asked, the order of the questions, and so on and so forth. That is so that you can familiarize yourself with the exam, so that when you go into your exam, you're not freaking out about what you're going to see. You're going to see something very similar that you are seeing in that lab. So for those of you that are in a Monday or a Friday tute, you are in a bit of strife because you obviously don't have class because it's public holidays. So a ticket has, on the forum, Grace has put up a message to get a ticket to attend a different lab, okay? I strongly suggest you do that, because when you do that practice exam, it's not just the practice exam. We get you to log into the exact same exam environment so that we can make sure that everything works for the exam. And so that you can actually see what that exam environment looks like, because you'll see what's locked out, what you can access, how you can actually, keep time. Everything kind of gives you the vibes of the exam, except your marks don't count. So, yep. So give is the same as your labs and your weekly, there's like weekly problem sets, not tests. So the give is, you will give your exam questions after you complete them. Make sure that you are actually giving those exam questions. Unlike your labs, we cannot see your auto tests. And if we can't see your auto tests, we cannot take your last attempt or anything like that. We need you to give your question. So make sure that all your questions are given. You will be reminded in the exam with 15 minutes to go, with 20 minutes to go, to please submit all of your questions. It is heartbreaking watching someone walk out of the exam having forgotten to give a question. So please, please, please make sure that you give your questions. Auto tests the same as they are for the labs, basically. So you will have auto tests in your exam, and the number of auto tests will diminish as you go further into the exam. We'll talk about that as we talk about the questions. And again, we do not keep track of the auto tests in the exam. You need to submit your questions. Really important. Okay, whew. There's an array hurdle, which is your question 2 or question 4. They are clearly marked in the exam. You have to pass this question, one of them, to pass this hurdle in the exam. By pass, I mean you have to get 50% or above in that question. You don't have to get full marks. So one of those questions. Question 2 is easier than question 4, but you've got 2 attempts to do it to get a 50% on either one of those questions. And then similarly, there's a linked list hurdle as well. It's a question 1 or question 3. And again, you have to pass that linked list hurdle. You have to pass both the array hurdle and the linked list hurdle to make it through the course. So even if you get 65% in the whole course, which is a credit, if you don't pass the hurdle, you have failed the course. And there's no exceptions for that. And the reason for that, whilst it may seem very, very harsh, is that when you move on to subsequent courses in computing, you will really, really struggle if you cannot pass one of those hurdles, both of those hurdles. So we're trying to make sure that you're not going to just put off some pain to the next course and the one after that. All of these questions are clearly marked on the exam as well. Okay, the exam is closed book, but the course website is open. You will be able to access everything on the course website. That means any lecture material or any code we've done in the lecture, any tutorial material or code, and any lab material or code. You will not have access to your own labs, but you will have access to our material. I'm going to put it out there. You don't really have enough time to look at it in detail. I have seen people open up lecture videos in an exam. You do not have time to watch a quick video. They're not quick. And also I do tend to yap a little bit, so definitely you don't have time for one of my lectures to watch it and solve the question. So make sure that you're prepared. You kind of know the structure of everything, what happened in each week, so that if you do need a reminder, you know which week to go to. Exam conditions still apply, okay? That means you can't communicate with anyone about the exam 24 hours from the exam start time. If you start to, a Reddit thread, we do go on Reddit. And we do go on other sites as well to check, because it does have implications and it is considered academic misconduct. Do not talk about, you can chat with the person that's just left how you found the exam and whatever else, but nothing in written forums. And no sharing of code. I know it seems to go without saying, but people love sharing their code. Don't share your code. Don't share it in the Discord channels. Don't share it on Reddit. Don't share it anywhere. Just don't share your code. Please, don't share your code. Okay. If you experience any issues during the exam, okay, the keyboard is janky, the mouse is not working, the monitor, I don't know, something is not working, you can't access something, maybe you're feeling anxious and something is just not quite going your way, don't just sit there and suffer. Raise your hand. There are invigilators in the room, and they can come and they can help you, okay? We know that during an exam, you might, not be at your, top speed to kind of for all the things happening around you. Let us help you if you need help. Just raise your hand. Don't sit and don't, and just suffer and think, life is ending. It's not, it's just beginning. 1511 is amazing. Okay, the exam. When you come into the room and you seat yourself, there will be instructions provided to you on how to start the exam. You cannot bring your phone into the exam. You will be asked to leave it at the front of the room. Your bags will be left at the front of the room. When you receive the email about the exam, you will actually be told what you can and you can't bring in. Please don't forget a water bottle. It has to be clear. You do get thirsty in the exam. It's hard work. So, yep. You cannot bring your own keyboard. I'm just going to proactively answer that, because if you bring in your amazing mechanical keyboard and someone is sitting next to you, I would probably slam that keyboard and throw it out the window if it was me sitting next to you, and that's why you cannot. But if you get into the room and your keyboard is revolting and sticky, please raise your hand. We have wipes to wipe it down. I also could not have worked on a keyboard that is disgusting. So please let us know. You will fetch the exam when you get in. Don't worry, there's instructions for all of this, and the prac exam has all of it. What that will do is it will copy across all the starter files. A lot of the questions have starter files. That bathroom is so popular and so loud. Oh, I'm just going to close this door. So it will copy across all of your starter files so that you're ready to go with the exam, and then you will kind of start. Okay, this is super important, okay? The fit to sit policy at UNSW, if this is your first exam. This policy says that by showing up and sitting the exam, you have declared yourself fit enough to do so. That means that special consideration will be really hard to get afterwards. Now, the number of people I have seen show up that should not have shown up to the exam, please don't show up. If you are genuinely unwell, you will get a supplementary examination, okay? And all you're doing by showing up is infecting everyone around you. Very much so. And especially if you've been vomiting, please don't show up. I do not have a HAZ suit and I cannot wear one, and I don't really want vomit on me, which has happened at basically every single exam of 1511 so far. So please, if you're not feeling well, for your own sake, you will not be able to sit through a 3-hour exam when you've just been vomiting, or when you've had a fever, or when you're not well. Panadol is not going to cut it. Please just stay at home, go to the doctor, get a medical certificate, and get a sup exam. Look at this. I really go on about it, but it's because I've been sick that many times from people being sick in the exam. So I'm very, very, very into this. Please do not show up. Now, it might happen that you show up to the exam and then an hour into the exam, you feel awful. The fit to sit policy says, I am fit to do this exam, but your body says, I'm absolutely not fit to do this exam. Listen to your body. Do not push through it. Raise your hand. Tell the invigilator you have started feeling unwell. It does happen that you suddenly start feeling sick. You have to stop working on the exam. You raise your hand, you tell the invigilator, and what we will do is we will hopefully get you into UNSW, the health service, to see a doctor. That's not always possible. They might be booked out. If they are booked out, you need to see a doctor within 24 hours of feeling sick. Otherwise, you will not be able to apply for special cons, okay? So please start kind of like just, if you're feeling unwell, don't push through it. Listen to your body, and you can get a medical certificate and apply for special cons. If you do get a supplementary exam, the exam is going to be in May, and it is in O week basically, in that week 26th to the 30th of May. If you need to sit this exam, it means you have to be available during those dates. You can't not show up to the sup, okay? And I've included a link for the details of the supplementary exam. The supplementary exam will be much the same as the real exam. The labs, everything is going to be, except for the questions, everything is going to be the same. The questions will be different. We will be running some week 11 revision classes, and more on that coming soon. So, yep, exciting stuff. So let's talk about the actual exam now that we've kind of done all the side stuff. So actually, what do you do if you're not feeling well? Will you show up to the exam? No, please don't show up to the exam. I beg you. I've had to call an ambulance like 3 times because someone's fainted. Just don't show up. Chill, relax, make yourself feel better at home. Okay, the format of the exam. There's 11 practical questions and a whole bunch of distribution. Guess what? You don't have to do all the questions to do really, really super duper well in the exam. If you're not aiming for a HD, crazy HD, forget about question 11. Don't even try it. Don't waste your time. So you've got question 1 to question 4. They are the hurdles, okay? Definitely try those questions because they are the most important questions. If you haven't passed one of those questions, just stay on them, okay? Try and do them. Maybe take a little break, 5 minutes, then look back, try and do them. Questions 5 to question 8, they're debugging questions, okay? So you'll be asked to understand and debug some code and find the errors in that code. Question 9 and question 10 are getting more difficult. They're programming questions again. And question 11 is not nice. And it's a programming question. It's worth 10 marks. And it's a bit of a boo question. I do love to read the ones that are done. But I'll put it out this way. So last time, let's say there's 1,200 students enrolled in this course. Only 30 people attempted question 11 and only 10 people solved it. So that it's not a, right? It's not a, like, the question is just there. It's for funsies, for those that are, you know, going strong. It is my hope and wish that you can attempt and complete the first 8 questions, okay? That means all the hurdles and all the debugging questions. And you will be able to get a pretty good mark with that, okay? More than a pass. More than a pass, way more than a pass. So it is better to concentrate on a smaller number of questions and to do them well than to do little bits and bobs of every question, right? Okay, I don't know why I'm going this way, but I'm going in a random order. Who cares about order, apparently? Okay, questions 5 to 8, they're the debug question. So they're your practical question. They are there to see whether you understand code, whether you can debug code. And you will be told, basically, debug the following code, make sure it produces the desired output. And you'll see those examples in the week 10 practice exam. Okay, then the rest of the questions out of them, they're all programming questions. So those are the only debug ones where you get the code, you've got to fix the code. The rest is you have to write the code. And the number of code, the lines of code you have to write varies based on where you are in the exam. The exam is 3 hours long with a little bit of time for reading to start with. So question 1 to question 4, which is your hurdles, they're 12 marks each. Question 9 and 10 is 11 marks each, and question 11 is 10 marks. And you can see how they kind of get less and less marks as they get harder. We want you to do really well on the first questions, and then the other ones are, you know, there for if you want to HD and so on. You can absolutely just do questions 1 to 4 and pass and then walk out. And I've seen people do that, right? The exam is worth 40% of your total mark, so you could be walking into that exam really effectively having passed except for the hurdles. So it's really up to you how you do it. You are not marked on style in the exam. I'll put it out there. So, but, okay, I will say you're not marked on style, but if I need to mark your question manually, which I do for all the hurdles, and I mark them all manually, really, after the ones that don't pass all auto tests. But if I'm marking your question 10, and I've got no idea what is going on, I am not giving it any marks. Whereas if I know what you've written and I can see where the logic is going, you will get some marks, even if no auto tests are passed, okay? So don't care about style, but please use white space and indentation, because otherwise we'll not be able to read what is going on if it's manually marked. And you want someone to be able to understand what's going on if it's manually marked. Okay, so our difficulty is, so we go in difficulty from question 1 to question 11, and the difficulty increases as you go. And again, you have access to auto tests, but you should not rely on the auto tests to think that you've passed the question. I have had some students where the function stub, not even like, they haven't written any code for the function stub, but the function returns 1 or something, and then the auto tests are passed halfway through. They have not written a piece of code, and they think that they should get half marks for that question. We check that, and please, if you don't have code, you're not getting marks, right? So make sure that you're not just relying on auto tests to tell you what mark you're getting. That's not how it works. There has to be some logic to it. Okay, harder questions will have less auto tests. So by question 11, There's a few auto tests, and then we just leave you to your own devices. Question 10, kind of similar. But the hurdles really test almost everything, right? They'll look at edge cases and boundaries. They're very kind to you. Still consider the edge cases just in case. Any questions so far? Okay, I'm going to also say when you fetch the exam and the starter code, when you have that reading time, take the time to read the questions, okay? And also take 5 minutes to plan how you're going to solve those questions. Don't just rush into code. And start with the easier questions. Go in order. Pass the hurdles first before going anywhere else. And I'll say it again, less questions but answered more fully is better than more questions with like one auto test passing for each question, right? Remember that the earlier questions are worth more marks anyway. The hurdles are worth more marks. So like a 1-dot hurdle question is worth 12 marks, whereas question 11 is 10 marks. So be mindful how you're going to go through the exam and solve it. Oh, sorry.
Do you get a pen and paper in the exam?
You do. You get one piece of paper, and you bring, and you can ask for more. And you bring a pen with you, because the pens that, if you forgot a pen, the pens that I have to give you are, they're awful pens. Okay, what a great question. Okay, yeah. Oh, yeah. Oh, what another great question. There is no DCC help in the exam. And no DCC sidekick. The only thing you have access to is DCC, and that's it. Yeah. Pretty comparable. And you'll see next week, the prac exam is very comparable to what you'll see in the actual exam. Okay, well that news was just, I feel like that news, we might need some chocolates to get everyone back after that news. Bit of a sugar rush, yeah.
Are we able to install VS Code extensions?
No, you're going to be sitting in the exam environment and everything will be locked out for you. It'll just be clean code and that's it. And that's that. Hey? I can't even remember if we have Vim access. Yeah, it's really basic. We really strip away everything. Yeah. I would use the editor. Yeah. It will be stripped down to be like, yeah. Oh, yay, go Bree. Okay. So you must pass one of the array hurdle questions or one of the linked list hurdle questions. Okay. Question 1 and question 2. One is a linked list array. Do not ever that. One is a linked list hurdle and the other one is an array hurdle. They are 1-dot questions, okay? They are like, oh, I'm just thinking to what maybe the array one is like 1 and like a tiny portion of a second bar this term. But it evens out with the other one. So if one is like a bit harder, the other one is a bit more simple. They'll be similar to your prac question 1 and 2. And you will have to create simple C programs in those questions. And I'll show you what they look like in this lecture today. Okay, we'll do a few that I've given examples of, and I'll show you what the code looks like. Our starter code has in it functions that you can use to test your code. I'll show you what it all looks like so that you're not thrown. Basically, the first 2 questions, very simple. You have to, if you're in a linked list, you might have to traverse and find something in a linked list. If you're in an array, you might have to traverse and find something in an array. Might be simple structs and some simple like scanf, printf kind of movement. No insertion or deletion, okay, at that point in time. That's for the next two questions. So something like, given a linked list, print the largest value in that list, okay? Like a 1 dot, and we'll do these questions at the end of today. Given a linked list, count how many square numbers there are in the list, and do not use math.h. You got to read the clarifications at the end of each question. They'll tell you what you can and can't use as well. Given two linked lists, return the difference in the number of items in the two lists. Yeah. So questions 1 and 2 will not have insertion or deletion, which means you don't have to worry about malloc or free. But question 3 or 4, you will most probably have to worry about malloc and free, depending what that question is asking. Maybe loop through an array of structs, gather some kind of information about them. And again, we'll do that as well. For an array, count the number of multiples of 3 in an array, or it could be something else. Now, questions 3 and 4, we're moving up in difficulty. They're 2-dot questions. 3 is a linked list, 4 is an array hurdle. If you have already successfully answered questions 1 and 2, it means you have passed both the hurdles and you are just now picking up marks from the exam. Yeah?
Does 50%, passing 50% of the auto test mean you can get 50%?
No, passing 50% of the auto test does not mean you will get 50% of the marks, because again, the return, whatever is in the returning might just be by fluke the same as what an auto test is testing for. So it looks like you've passed the auto test, but you actually haven't. Yeah.
If you don't do a return thing, is it like a pretty good indicator?
If you have passed every single auto test, that's a pretty good indicator that you are okay.
I mean, if you've passed a few of them, but you haven't done the return, is that a pretty good indicator of where you're at?
Usually, yeah, but if you test it manually and it's working, that's a pretty good indicator that you're on the right path. Because if you have we try not to give you a printf statement so that you don't fail auto tests because of a space. We usually do the printfs ourselves so that you're just returning something to print out. So it just depends. Test it yourself. Yeah, that's the good indicator.
Do you have to worry about the printf, the new lines and spaces?
No, not in the exam. That would be really horrible. Yeah. Okay. Now, this is, yep.
If we fail an auto test, does it list us why we failed the auto test?
It'll say which auto test you failed. You can kind of see what's going on.
Is it like what we have in the regular homeworks where it'll be
Yeah, it tells you which, it'll have the numbers that have.
missing a new line or incorrect output?
Yeah, but you should not, so what I was saying before, sorry, I wasn't saying it very loud, but we try and keep printfs out of the exam. That is not the reason we want you to be failing. Usually we printf the statement. You will just give something to that statement to print out, but the printing will be done by us. Yeah?
You can give the actual output and expect the output.
Yeah. Okay, so this is where you might need to do some insertion or removal of nodes, and that means you will need to malloc or free. And test more difficult conditions. You might need to keep track of more than one thing. So there are harder applications of a linked list and a harder application of an array. You might need to do a few traversals of an array or something like that, a 2D array, depending. Okay, 9 and 10. 3 dots. If you have been doing your labs and you have not done a single 3-dot lab, don't try these questions. Focus on the first 8 questions. I promise you, it's not going to suddenly become a miracle in the exam where you're back, okay? You can attempt it if you've done the first 8, but don't waste time. The indicators are there to show you what it is that you should attempt and what you should try and do really well. So question 9 is usually a harder manipulation of arrays. It might have some sort of string manipulation. And then question 10 is a harder manipulation of linked lists, and it might be a more complex problem itself that you need to solve. So not even the syntax of the code, but the actual problem that you need to think through and solve yourself. And then question 11 is kind of a mixture of 3 dots and skull. If you're aiming for a super HD mark, you will be attempting this question. Otherwise, just don't even bother. And lots of our, like, Bree, did you do question 11? Oh, John? Yeah, that's true. What about you, Daniel?
I think I got like 3 marks out of like the 7.
Ah, well, I can tell you, Sophia, for those of you that have Sophia, instead of doing question 11, she wrote me a love poem in the comments. And, you know, then she became a cheat. No. No, so didn't even attempt it, right? I mean, if you have time, fun comments are life. But also really not good style, but I'm not marking for style, so I don't mind. So this question is basically, you know, anything that has been in the challenge exercises or anything that's kind of a lot more difficult. And you'll have a practice question 11 that you can see the difficult level of this, okay? And again, partially passing some auto tests or partially doing some logic does give you some marks, okay? Okay, what should you study? Yeah.
If you haven't done any read-ups, if you grind them out before the exam, do you reckon you could still do question 9?
Yeah. If you understood, if you grind them out and you understand something in them, then you will be able to get at least partial marks for them, if not all marks, yeah. And if you go back now, you will be able to do a lot of the 3 dots you haven't been able to do because it's just you're building your understanding. All right, so you should probably know how to use both arrays and linked lists when you go into this exam. Yeah.
Do they care about illegal elements?
You know, I do. It depends what they are. I don't want to see break. I will forgive it. I won't take marks off. But when I see break, everyone's always so aghast. Oh, you can use break. There's no problem. I use break a lot. But if you are beginning to program, break allows you to not understand what is the exit condition out of your loop and not work through it, right? There's a reason we say no break in foundational programming. You can use it as you go on, and it's the same with other things. You're not going to be penalized for it, and if the code is clear, it's okay. But if the code starts to become messy, not okay. Yeah. Are there what, sorry? No style marks. So don't care about style, but I need to be able to read it to manually mark. And it's not just me manually marking. There's too many exams and not enough time. There's others manually marking as well. So we need to be able to read your questions, answers. Okay, so go back and redo all the exercises that you might not have done before to practice. There's also going to be revision exercises on our site. Go and do them. They're good. They are good practice as well. Just understand everything. Okay, so you need to be able to understand very well arrays, manipulation of arrays, linked lists, structs, some enums. I don't know if enums are so important. If, loops, you know, functions. But then if you're going on to question 9 and 10, you really want to understand strings as well and pointers and memory allocation. But if you're not planning to do those questions, that's, you know, not as important then. Okay. I've kind of talked about this, but I'll just... So all hurdles will be, if you haven't passed all the auto tests for the hurdles, all the auto marking, they will also be looked at manually, okay? We really do want you to pass. It's not, you know, we don't want people failing that have made a small typo that has resulted in them not being able to, you know, get through the hurdle. If it is a small typo, you will probably get most of the questions when it's manual, most of the marks for the question if it's manually marked, okay? So don't stress until you receive your marks, basically. And I will stress it again, marks are given for correct code, not for passing auto tests. So if we look at your questions manually and we see that your logic is sound and you are almost there, you will get most of the marks even if you have not passed any auto tests, okay? Yeah?
So if we pass all the auto tests, including the hidden ones, would you look at our hurdle?
No. Why would I look at it? You've
Hypothetically, if I hard code
You will not be able to hard code. We auto test for that. There you go. I will tell you this right now. You cannot hard code. We test for it because of the hidden auto tests. All right. This is asked all the time, the auto test questions. Okay, perfect. Oh, you've got this. Maybe. I hope you do. Exams are always... I was really bad at exams when I was a student. I don't like silence, so I find exams really, really difficult to do because I can't concentrate. And just be prepared. And if you know that sound annoys you, bring like an earplug to stick in your ears, right? And if you know, because there's going to be someone sitting next to you and maybe another person sitting there, you are separated, but you can still hear them. And just know, if you can hear someone typing all the time and you're thinking, I don't know what to do here, Sophia was typing and she was writing a love poem, right? So you don't know what that person's typing. Don't worry. Focus on your own computer and what you are doing yourself, right? So just be nice to yourself as well. Make sure to breathe in the exam. Don't freak out. Sometimes the questions look worse when you've just looked at them and then you don't know what's going on. Just read them again slowly and approach it, step by step, right? Set it out in your code how you would solve it as well. It helps to kind of bring you back down to earth and not freak out. Okay, linked lists, draw diagrams. You have the piece of paper. Go through the code like we do in the lecture. Pretend you're the computer. That will give you where it's, where it's might be making a mistake. And again, revision classes in week 11. Okay, any questions about the exam? How you all doing? Everyone good? Oh, so good. Maths exam and what? Physics exam? Yeah. It's because I renamed the file the wrong thing, so I will put it up at halftime. Halftime, we're not playing sport at the break in the lecture. Any questions about the exams? Because otherwise we'll take a little break before we do coding. Questions? Questions? No questions? Any questions online? No? No questions? Oh, all right. All right, we will do a Kahoot when we come back. Let's have a little break, and then we'll Kahoot, and then we'll do some questions. Who's yawning? All right, this is a big Kahoot. I overcooked a little bit. So there's like 12 questions. Good luck. May the force be with you. Here we go. I need sleep. That's going to be for the next 4 weeks. Good luck. Still joining. All right, shall we start? Start? Start. Let's start. No. Oh. All right. Good luck. Just like the exam, we start with a 1 dot. All right, not bad, not bad. Very nice. A node contains data and a pointer to the next node, which is what makes it a linked list. James, we haven't had James at the top. There we go. Reverse linked list. Oh, that really hurts. So to insert a node, which would be a question 3 or 4 in a linked list potentially in an exam, first you allocate some memory for a new node, then you initialize the data of the new node. Then before you update the head pointer, you should update the next pointer of the new node, otherwise you're going to lose what's going on, what follows the old head. Oh, it's a completely different table. What happened with that question? And someone was very confident, Kahoot winner. Oh, these questions are really hurting. Okay. Oh, Kahoot winner. Someone's feeling very confident still there. Oh, nice, nice. Kahoot winner, moving to the top. This one should be a quick one. We've said it a few times. Hey? I had it last week. Well, let's... What? Yeah. Yeah. All right. Okay, pretty good. The previous question was searching for a node. I'll breeze on it. Yeah, 2 answers were correct. Oh, very nice. Not bad. It said S in brackets online. That's why. And after this, they start cooking, sorry. Excellent. If you want free, then you need to delete a node. Okay, still at the top. Oh no, this is the last simple one. Contiguous is consecutive, one after another. All right, so that could be an English thing from online, or that could be an English thing. Okay, get used to the word contiguous. You use it all the time in computing. And then after that, we keep it simple in computing. Just means continuous memory, one next to the other. That. Ooh, here we go. Okay, now it's a chunk of code. Not the kind of surprise you'd want to see in your life. What a spread. What a spread. So notice that it's counting up the i's and it's going to current next is not equal to null. The question is really just done to cook you up and serve you raw. Yay! Oh, very good. It's going to throw a runtime error, not a compile time error. or return 0 or null. And that's because if the list is empty over here, you are going to access the next element of an empty list, so you're going to dereference null. Oh, Alan is back. All right, I think this is the last one. No, it's not. Second last. Not bad, not bad. I reckon it's the current next that threw people off. All right, last question. Amazing. Yep. It's going to return the pointer to the head of the list. All right, let's see who is on the podium. Oh, Kahoot winner. Not quite a winner, but you're on the podium. Nah, oh, lots of confidence here. And number 1 is Alan. Got to play that video one time. Is anyone here from these 3 people? Yay! Which one? The confident one or Alan? Oh, confidence. You were on top for so much of that. All right. I mean, overall, it was okay. Okay, time to do some coding. Yay. So also actually, your assignment 1 marks are going to, how is that still playing? Did I not close it? No, I did not. Your assignment 1 marks will be released after the lecture. If you can see any issues with the assignment mark, okay, it's going to be on your normal, like where you give student. If you can see any issues, just email us, okay, at cs1511@unsw.edu.au. Okay, we're going to do the question that was modify the function largest to return the largest item in a linked list. So when you open up the exam question, your starter code might look something like this. Not this, you won't have an example in here. But you want to traverse a linked list and find the largest number in it, something like that. But the most important thing you'll see, you'll have some includes. You'll have a definition of a struct node that you won't need to do anything with. Then you will have a function that you actually need to write yourself, and you will put your code in here. And most important, don't forget to change the return value. And then you will have some other stuff that you would not need to touch, including a main function and what I said, which gives the printf. And it will also have, in a linked list question, most likely it will have something like this function here. You do not need to understand it. You don't need to do anything with it. What this function is doing is it's taking some command lines so that you can test your own code. It means when you run your program, you can type in a linked list and it will convert it to a linked list, right, from the items on the command line. You don't need to do anything with it. I'll show you how to use it in a second. So basically, the question is to modify the function largest, to traverse the linked list and return the largest element in the linked list. Okay, so the first thing I want you to do in the exam is to take a minute before you start writing any code. And to think how you're going to solve it. So, who has some steps for me that we can use to solve this question? No one has any thoughts at all? I hope that this is better in the exam. This is 1 dot. Question 1. Thoughts. What a great thought. Okay, check for an empty list. Online, someone's curling up into a ball, not crying. No, don't do that. And don't cry, you'll disturb the people next to you in the exam. Got to do it quietly. All right. Anything else? Did you think maybe you'd want to traverse the linked list? Yeah? Yeah, amazing. Okay. And then we're going to traverse list. Up here, first step. Yeah, absolutely. Okay, we're going to traverse the list and we're going to look for something. What are we going to look for? How are we going to keep track of it? What are we going to do? Yeah.
Should we initialize a variable called largest?
Oh, we absolutely should.
And then if for each like element, if it's larger than the one before it, then you actually set largest to be that element.
Yeah. Okay, so we initialize a variable to keep track of largest number. And we traverse the list and we look for, now someone is collecting tears and drinking the tears in the exam. I don't think it's a good use of your time. Strongly recommend against it. Okay, so we're going to do a whole bunch of things. Traverse the list, look for items. Wow, this is a really good description. Look for each data point if it is larger than the last one and update if it is. And then at the end we're going to return largest number. Okay. Okay, someone is, well, you need a water bottle to collect the tears into, surely. You can't collect them into your empty hand. Please don't just, it's an exam, right? I'm just going to put it out there. So what? Your life is not going to, like, you're more than an exam. It doesn't really matter. You know, it's not a big deal if you don't do as well as you had hoped to do. It's, you can do this, right? It's just an exam. Okay. Let's write some code. Let's actually perform those things that we have done. Okay, so the first thing we're going to do is we're going to have a current. And we're going to set it to the head of the list. Now we're going to use this current to traverse the list. I know it is week 9, but it makes it really hard to hear online when there is buzzing in here. Okay, so we've set the current to the head of the list. We're going to be doing some looping, so I'm definitely going to have a while loop in here. And in my loop, I'm going to clearly be moving my things along, so I'm just going to put the basic structure in. Okay, so I've initialized a current node to traverse the linked list, so I've done this one. This one is done. And I haven't done this one. Why don't we do this next one first? Initialize a variable to keep track of the largest number. So I'm going to say int largest, and I need to initialize it to something. What should I initialize it to? 0. Okay. And if I do initialize it to 0, when would this fail? Empty list, depending what you're doing for the rest of the code. It would just return 0, and based on the spec, you could be in for a treat. When else would it fail? Yeah.
If it's only negative numbers.
Absolutely. If it's only negative numbers, your question is not going to give the right thing. It's not going to give the largest number in that linked list. It's just going to give you 0, which didn't exist in the list. Okay. I'm going to keep it as 0 for now, but we will change it because otherwise it will fail if you have a list of negative numbers. Okay, so we've got kind of halfway, we've done that. What should the condition be to traverse a linked list? Yeah. Do I want to get through the whole list, or do I want to stop at the last node, not go through the whole list? Yeah, the whole list, okay? Because I want to check, otherwise I don't want to miss out on checking whether the last element is the largest. So that means I'm going to check for current is not equal to null. That's going to get me through the whole list, and it's going to make sure that I traverse the whole list. Okay, great. I have just a basic structure, and over here I'm going to return the largest item, which is what I'm going to use to track what is the largest thing in my list. All right. And we're kind of traversing the list. We're not doing much. Good luck for the exam. Okay. Where are we at? Check for an empty list. What will we do here? How will we check for an empty list? Yep. So we're going to check if current is equal to null. What am I going to do? Okay, doesn't, yeah. Print error, don't really want to do that in an exam. You don't want to be printing in an exam. Don't print. It will make you fail some auto tests most probably. What are some other things we can do? I could return null, but my return function is an int, so that's not going to work. Hey? I could return the largest, absolutely, but again, I mean, depending what the spec of the question is, and you will be told what to do in an empty list. So that could be fine to do, absolutely, to return the largest. So right now we're assuming some things. Okay, you could do that, and then, you know, you're living your life to the fullest. Again, for an empty list, you might be given an assumption that if it's an empty list, return 0. Now, what you could also do is you can check. No, let's just go with this for now. Okay, great. Now, if my current is equal to null, then I'm going to return the largest. Otherwise, what do I want to do? Yeah, so right now we've said largest equals to 0 is not really going to work that well in a negative list. So we want to change that largest now. Yeah.
Set largest to the data I have.
Yeah. So what I want to do after checking if it's an empty list, I'm going to assign largest whatever is sitting inside my current data. So that's going to be the first element in the list. I'm going to say you are the largest thing, and now I'm going to check if anything else is larger than that first thing in the list. Okay, so whilst current is not equal to null, I'm now going to need to check something. How will I check something? And what will I check? Yeah. Yeah, so I'm going to check if whatever is in my list, my current data, is greater than the largest element. And if it is greater, then I'm going to assign it into the largest variable. Otherwise, I'm going to just move myself along. Okay, how are we feeling? Do we think that we've done it? Everything's going to work?
At the if statement before, you need to do an else and then include the largest in while loop.
Very good. Okay. I was going to fail it first. Okay, so who heard that? Well, you were sitting right next to him. You heard that. Let's fail it. No, I'm pleased someone is participating and listening. Okay, let's compile it. Oh, no, I shouldn't have. Anyway, it doesn't matter. Let me just compile it again. Okay, so this is what I was saying to you before. Those extra functions that we give you are there for you to test your code with. So now when you're running your code and you're like, I don't know how to test it, the strings to, I've forgotten what the function is called, strings to Strings to list is the one that converts whatever we enter in the command line to a list. You don't have to worry how it does it. But I basically run the program and give it some command line arguments, and those command line arguments get turned into a list. So let's do it with a list. So the list is 3, 4, 5, 6, 7. Amazing. That's working. What should I try again? Let's pretend that I have failed all the auto tests, or there are no auto tests, and I need to test my own code. Oh, shock, horror. What am I testing? Pardon? Okay, well, we know that's not going to go so well for us. Okay, so we test negative numbers. Oh, that's gone quite well for us, actually, in that case. Yeah. Great idea. Let's try an empty list. Okay, that's given us a 0. What else can I try? Right now they're in order of, I've put the largest number at the end of the list. Should we try the largest number at the start of the list? Great. Where else can I try that largest number? Yeah, in the middle of the list? It's all still working. What magical being? Hey? With just one thing? Okay. All right. Who would like to run through that code to see why it is working, I guess? If there would have been a different condition in that if statement, it would have gone to, yeah. Who wants to diagram the code? Anyone? Can you poll it, please? No one wants to answer. You want to diagram the code, John. Good for you. It's so awkward, isn't it, leaving through the front? Oh. Never be able to live that down now. But you don't have to, because it's the last in-person lecture. Yeah, because next Monday is Easter Monday. All right, let's have a look. Oh, God. Let's have a look at the diagram at the code. Okay, and I'm going to go do some magic. All right. Now let's say we've got our list that we have put in. And the list is, oh, it's doing it again. Why is it doing it again? Bloody hell. And we're back. Okay. Okay. So let's say our list is and I want the largest number from this list. Okay, so these are the numbers that we've entered. The first thing we're doing is we've given the head of the list to our function. So that means that the function has received the address of this node over here. And the first thing I do is I make it the current node as well. So I assign my current node to the address of the head. I then declare a largest variable and I assign the value 0 to it for now. Okay, and if my current is equal to null, so if there's nothing in the list, and in this case there is something in the list, so I'm going to skip this if statement, and I'm going to go to the next line, which now says largest is equal to current data. So what it's doing is it's assigning a new value to largest. It's going into current data, pulling out the data here, and assigning it to the value largest. I then start looping through my list. So current is not equal to null. It's not equal to null. So I'm going to go into this list, into this loop, sorry, and I'm going to check, is current data greater than largest? So I'm going to pull out the number 3 and check, is it greater than 3? It's not greater than 3, which means I'll skip this if statement, and I'm going to go straight to here, which means I'm going to move my current along to the next node. Now I'm sitting at this node, and I'll go back into the loop to check, is it equal to null? It's not equal to null, there's a node there, and I'll check again if the data in my current greater than largest. So is 4 greater than 3? Yes, it is, which means I'm going to go into this loop, and now I'm going to assign that into my largest. So my 3 will now become a 4. And then I'm going to move my current along. So my current is going to move to the next node. So the current is now over here. So then I'm going to check my loop again. And when I check it again, current is not equal to null yet because it's got a value. And I'm going to check if current data is greater than largest. Largest is 4, current data is 5. Still true, which means I'm going to go here and reassign largest to the value inside current data. Then I'm going to move my current along to my next node. So current is now over here. I'll check again whether current is equal to null. It's not because there's a node there. I'm going to check again if the data in current is greater than the largest. So is 10 greater than 5? It is, which means I'll reassign the 5 with a 10 over here. And then I'll move my current along. So my current will now shift over to the null pointer here. So when I go back into the loop and I say, okay, is current equal to null? Yes, it is. It means I exit out of the loop and I return the largest element, which is 10. So I'm going to come back to the main function over here with the number 10 because the function gets called here with the head. How's everyone feeling about that? Good? John, can you now just check the fields for this question? Does it make sense? Oh, you came back. I'm so sorry that I made fun of you then. All right, quick game's a good game. Any questions? Thumbs up, thumbs down? Any things, thoughts, feelings? None? Yes? It looks like what? Head never equals to null. Is that what you're saying? Where? In main? So it depends. So this strings to list function, it takes everything on that command line. So if I don't give it anything over here, then it will return a null here.
But if you give it the name of the program you run, it's still technically an item.
We don't count that item in the list. We start collecting the arguments from the one after it. So over here, we give it we go from the next one over. Yeah.
But then how come it didn't give an error when you just nothing?
So because we look for whatever is sitting, if there's nothing in that first place, we say return just null. So it can do an empty list. But not something you have to worry about as well in the exam. You just assume that we've done the right thing. And we have tested the exam, so it won't, no, I'm not going to say it, I don't want to jinx it. Yeah. Yeah, let's do an array question. I don't want to jinx anything about the exam. A few years ago, we had a fire start, so that was not that much fun. If you do hear the fire alarm, we need to quickly safely, no bags, leave the rooms. Okay, let's do a. Now let me remember where an array question was. I was the multiple.c question. Okay, for an array question, if we do an array question now, let's say we've got this multiple.c where we have to move through the array and we have to count the number of multiples of 3. So in an array question, you'll see something that looks like this, where you're going to have this main function. You'll notice the main function is sitting underneath. It's because we don't really care about it. We actually remove the main function when we test your code and we use our own to plug it in with. So that main function is really just there for you to test your code. It's not for us. So do not write any code in the main function, otherwise you will not get any marks, because we remove the main when we test. You will be told, please do your code inside a function instead, and that's the function that gets called from main. So you'll see also in an array question, it's probably going to have the array. You're welcome to change the array itself to test your question, so that you can see whether your question is working. And then we call the function with some things that we give it. Okay, so we've got an array question. Haven't done arrays for, 4 weeks now. Everyone's forgotten about arrays and moved on with their life, and you're now back. So what would we do in this question? How would we solve it? Oh, absolutely. When you see an array, you want to have a for loop. So at some stage, I'm going to need a for loop because I need to make my way to traverse the array to find what it is that I'm looking for. So anything that we want to say about how to solve it? Hey? Did someone say something, or is it just... A counter, yes, we do need a counter to count them. That should be, I'm going backwards. Okay, so let's declare that first then. If I want a counter, I'm going to declare a counter, and I'm going to initialize it to 0 because I haven't really started counting anything. Okay, then I'm going to go into a for loop to go through my array. So I'm returning the number of things in the array that are multiples of 3. But you're right, if I was actually returning the first item in the list where it's a multiple of 3, then yes, I would have set it to the first element. So you're going to see that kind of question a lot in programming, where you set the first item as the first item in the list, and then you search through and compare. And we'll do a few more of those. Okay, so for int I is equal to 0, I is less than what? Yep. So you do have a size defined here, so you use that as your, size is passed in over here, sorry, of the array, and then I++ to move it along. Okay, what is our condition now for checking whether or not something is a multiple of 3? Yeah, so we're going to check whether something's sitting inside this array. So this function gets passed an array. It's called ARR. So I'm going to check whether whatever is sitting inside the array at index I is divisible by 3. So modulus 3 gives me 0. And if it does, then what do I do? Yeah, so then I'm going to update my counter by 1. And then what will I return at the end here? Do we think this is good? Feels too easy, doesn't it? I have to say the exam question is probably a little bit harder than this.
Do we have to check an empty array?
Not if you're told not to. You will be specifically told especially in the hurdles, your hand will be held and then it will be released. Go out into the world and prosper. Okay, so let's check it. So my array has these values in it. What should it return hypothetically if it was operating as required? I know, negative numbers, they always throw everyone off. Okay, it should return 2, so let's try it. Okay. Oh, because of 0, yes. But you will be told in the exam question 0 is not a multiple of anything. So you would then, what would you need to do? If we had that condition, this is a good, let's go on the fly here. Yeah. Yeah, so I would check inside my if statement if it is a 0, and then I do not count it. Otherwise, I do. So over here, we could check whether that item is 0, skip over it, and then count it afterwards if it is not. Then check else that it's divisible. Yeah? Does everyone feel very good with this question? This is a little bit of a false sense of security for the first arrays hurdle. But like similar vibes, you would need to traverse the list once, okay? And find something in that list potentially. No surprises in the exam. Maybe just small ones, but nothing that's going to be awful. Okay, we're going to go through all of them. So which questions should we do now? Back to linked lists? String, we're not up to strings. That's going to be next week. There's definitely, strings are coming because it's useful for the debug questions as well. Oh, thank you. Thank you, John. Oh, question, yeah.
Is that like last week of lectures?
Is the what?
Is this our last week of lectures kickoff?
No, we're going to have a lecture next week where we're going to do some of the harder questions in the exam, so you get a kind of feel for those as well.
Okay. And so is lecture 2 tomorrow just going to be more of this as well?
More questions that you will get in the exam. I wanted to do a lecture program, but no one wants to do it, so like a bigger linked list program, but everyone wants to do exam stuff. Everyone's freaking out about the exam. Don't freak out. Okay. Okay, great. Let's do one more question today, and then we're going to call it a day. Let's do a linked list. Let's do a difference one, just because it's slightly different. So in this question, you get given 2 linked lists, because 1 linked list is not enough. So your function receives a head 1 and a head 2. So the head of the first linked list and the head of the second linked list. And you need to return the difference between the number of items in the first linked list versus the second linked list. All right, what are we feeling? And again, you'll see most of your linked lists will have this strings to list, which is what allows us to test your functions. Okay, let's do it. What will we need to do to solve this function? Whatever you do, you're probably going to need to traverse something. Yeah? If you're finding the difference between the numbers of items in the linked list, what do you think you need to do first? No, you will be asked to use, so like in a linked list question, you'll be asked not to use arrays. And one of our tests is checking that you did not use arrays to solve it.
So there's not going to be a question where you have to use both of them?
In the later questions, there might be, but not in the first hurdles. It'll either be one or the other, and it will check what's using what. Just because they're hurdles, and we need you to be able to show demonstrate understanding for arrays and for linked lists. Okay. Yes, someone online is coming to the good. I'm going to need to loop through the list and count items in that list. And then do the same thing, loop through the second list and do that again. Okay, great. And then I'm just going to I'm going to subtract them from each other and return the difference. Yeah. So I'm going to okay, so let's say we have two, and this is another good thing with linked lists. Let's say the first linked list is going to be 3, 4, 5. The second linked list is going to be 5, 6, 7, 8, 9. What should we return in here? What's the difference between the two? 5 minus 3, yeah.
Oh no, like all of them.
Huh?
Aren't we doing 3, 4, 5, minus 5, minus?
No, you're doing the number of items in the linked list. 2, thank you. Yeah, you really want to work inside the lists with the data in them. So you should return 2. Now, if I do this linked list first and I subtract it from this linked list, what am I going to get? How do I combat the fact that I could do 3 take away 5 or 5 take away 3 and I do not know which is the shorter list? Absolute value, yes. Okay, so that's something that you should check for if it's something that is happening. Okay, so the first thing I'm going to do is I'm going to have 2 currents. And I'm going to set the first one to the first head and the second one to the second head. Amazing. I am ready to loop. What else do I need to keep track of? If I'm counting the number of nodes in each list. Amazing. Yep. So I'm going to declare and initialize 2 counters, both of them set to 0. And what do we do next? We're just going to do a loop to count. I want to visit every single node or stop on the last node? Every single node. So whilst current is not equal to null, because I want to count every single null, every single node. I'm struggling with my words as well. And the list is called current1. And if there is a node there, I'm going to increase my counter by 1. And then I'm going to move my list up by 1 as well. Oh, it really struggled down when it's called something else, not current. Okay, that's going to count the first list, right? Okay, let's keep it simple. Let's count the second list. I'm starting basic. These questions will get harder. Okay, we've counted. Okay, we've now got, hypothetically, 2 things, and now we need to return the absolute value of them being subtracted from each other. So I'm going to do absolute value, and I'm going to do counter 1 minus counter 2. Hey? You could just multiply it by minus 1 if it's, you could check as well and multiply by minus 1. Okay, should we try it? So if you have 2 linked lists, you will be shown in your spec. You don't need to look at the code. Shh, just a few more minutes. I promise this pain will be over soon. They will be separated by a dash, but you will be shown this in your spec of the question. You will not need to look at the code. Okay, so if I'm going to do I'm going to compile it. And after I compile it, when I run it, I'm going to give it the 2 lists. I'm going to do 3, 4, 5. The dash is what separates the 2 linked lists. So 5, 6, 7, 8, 9. No. So it should return 2, and it does. Amazing. What would I try to check that my function is working as I want it to? Yeah, let's try a null for one of the lists. So let's do a nothing linked list. Yep. What else should I try? Null for both. Yep. What else should I try? Yep. Okay, and then what else should I try? So we've done everything where there's something happening. Then there's the nulls we've tried. That's good. What about swapping the order of the list? So the bigger list first to the smaller list. Okay. Seems to be functioning as we wanted to. Any other ways that we could break it? No, it's a... Pardon? Like, just in a different way. Shouldn't make a difference because we're not looking at them, but always good to check. I'm struggling with numbers now. All right, still good. Okay, so I think that's safe, right? That's probably still a little bit more simple than what a one dot question is, but we're moving there. So tomorrow we're going to do like the one dots that you might see in the exam, okay? But still the thing is the same, is that you will traverse it once and you will look for something, either in the array or the linked list. All right, we're going to call it, I think. But I hope that nothing. I'll see you tomorrow. I hope you have a good day, I guess. But, and a good luck with your assignment 1 marks.
You know how this just gives you the difference between the number of elements? What if it was what if the question asked, what is